Dr. Sarah Chen's headlamp cuts through the darkness of the cave system, 200 meters beneath the Nevada desert. The year is 2019. She's following a seismic anomaly that shouldn't exist, a void where solid rock should be. Her breathing echoes off walls that haven't seen light for millions of years. The air tastes metallic, ancient. Then, her light catches something that makes her stop mid-step. The wall ahead gleams, not with moisture or mineral deposits, but with something manufactured. Glass, smooth as a mirror, extending beyond the reach of her lamp in every direction. She approaches slowly, her geological hammer trembling in her hand. This shouldn't be here. This can't be here. The rock layers she just crawled through are 65 million years old. She touches the surface. It's warm. Behind the glass, something moves. Not alive, she tells herself, just shadows and reflections. But as her eyes adjust, she realizes she's looking through into another chamber, a vast space filled with structures that hurt to perceive, geometries that seem to fold in on themselves. And everywhere, covering every surface like frozen lightning, are patterns. Mathematical, deliberate, waiting. 3 hours later, Dr. Chen emerges from the cave system. She will never speak publicly about what she found. The site will be sealed within days, officially designated as structurally unsound. But in hushed conversations between scientists who sign papers they're not allowed to discuss, a single question spreads like wildfire through the geological community. What if we're not the first? What if Earth has worn the crown of civilization before, not once, but many times? What if beneath our feet, locked in stone older than the dinosaurs, lie the bones of technologies we haven't even dreamed of yet? This is the story science doesn't want to tell, not because it's false, but because it's too strange to fit inside our carefully constructed understanding of the world. It's the story of patterns in the rocks that mirror our modern mistakes too perfectly to be coincidence, of signatures in ice cores that predate humanity by eons, yet look exactly like industrial pollution, of a planet that might be trying to warn us through the only language that survives across deep time, the geological record itself. Some stories are too important to prove before we tell them. To understand what we might be missing, you first need to understand the crushing weight of geological time. A human lifetime, maybe 80 years if you're lucky, is a flashbulb pop against the darkness. Recorded human history, all 6,000 years of it, is barely a geological heartbeat. Our entire species, Homo sapiens, has existed for perhaps 300,000 years. That sounds like forever, until you realize it's only 0.0067% of Earth's history. The planet is 4.5 billion years old. That number is too big to mean anything, so let's shrink it down. Imagine Earth's entire history compressed into a single year. January 1st, the planet forms from cosmic debris. For months, nothing but volcanic hellfire and asteroid bombardment. Life doesn't even appear until late March. Simple, single-celled organisms that do nothing but exist and divide for months on end. By November, we finally get complex life. The dinosaurs don't show up until mid-December. They rule for what feels like forever to them, actually just a week and a half in our compressed year. Then, the day after Christmas, an asteroid wipes them out. Humans, we appear at 11:36 p.m. on December 31st. The pyramids are built at 11:59:46. The Industrial Revolution begins at 11:59:56. Your entire life happens in the last fraction of the last second before midnight. Now here's the disturbing question. In all those months before December 31st, in all that vast time when complex life existed but humans didn't, how many other species might have looked up at the stars and wondered if they were alone? How many civilizations might have risen to heights we can't imagine, only to fall so completely that we don't even know to look for their ruins? The geological record is like a book where someone has torn out most of the pages, burned half of what remained, and then scattered the ashes across the entire planet. We're trying to read this story through fragments of fragments, making assumptions that nothing important happened in the missing chapters. But sometimes, if you know how to look, you can find places where the pages weren't quite destroyed, where the story bleeds through. In 1972, French scientists at a uranium processing plant made a discovery that shouldn't have been possible. Uranium from the Oklo mine in Gabon, Africa, was depleted of uranium-235, the isotope used in nuclear reactors. The only explanation that made sense was impossible. This uranium had already been through nuclear fission, but the rock was 2 billion years old. Further investigation revealed the truth was even stranger. Deep underground, natural nuclear reactors had operated for hundreds of thousands of years. Groundwater acted as a moderator, uranium concentrated in seams reached critical mass, and the Earth itself achieved controlled nuclear fission when the planet was less than half its current age. If nature could accidentally create nuclear reactors 2 billion years ago, what else might be possible? What technologies that we consider uniquely human might actually be repeating patterns that Earth has experimented with before? Dr. James Morrison, a geologist who spent 3 decades studying the Oklo reactors, told me something shortly before his death in 2018 that I've never forgotten. We found those reactors because we knew what to look for: depleted uranium, specific isotope ratios, fission products. But what about the signatures we don't know to look for? What about technologies we haven't invented yet? They could be all around us, and we'd walk right past them because we don't have the vocabulary to see them. He paused, staring at a piece of Oklo uranium ore on his desk. The really terrifying thought is that maybe we have seen them. Maybe we've been calling them natural phenomena all along. Every geologist knows about the KPG boundary, that thin layer of clay that marks the asteroid impact 66 million years ago. It's found everywhere on Earth, a planetary scar tissue containing iridium, shocked quartz, and tiny glass spheres called tektites. It's our proof that the dinosaurs died in a cosmic catastrophe. But there are other layers, other boundaries, and some of them tell stranger stories. The Permian-Triassic boundary, 252 million years old, marks the Great Dying, when 96% of marine species vanished. But the chemistry of this extinction is bizarre. Carbon isotope ratios shift in ways that mirror exactly what we see from massive fossil fuel combustion. The amount of carbon released into the atmosphere matches what would happen if you burned every drop of oil, every lump of coal on Earth, all at once. Scientists explain this through massive volcanic eruptions in Siberia, which they certainly were. But volcanoes don't typically produce carbon signatures identical to refined petroleum burning. They don't usually release carbon in such a narrow time frame, geologically speaking. Dr. Michael Rothman studied the PT boundary for 40 years. In his private notes, published only after his death, he wrote, "The patterns are too perfect, too familiar. It's like looking at pollution data from the 1950s London, but it's a 250 million years old. Either we're missing something fundamental about volcanic processes, or..." He never finished that sentence, but I will. "Or we're looking at the signature of something that wasn't entirely natural." Consider the layers themselves. When geologists take core samples, they sometimes find what they call discontinuities, places where the expected pattern breaks. Usually these are explained by erosion, by gaps in deposition, but some discontinuities are different. The rock above and below shows continuous deposition, no time gap, but suddenly the chemistry changes. Mineral structures that should take millions of years to form appear in bands just centimeters thick, as if something accelerated the process, as if something was engineering the geology itself. In Antarctica, buried under 2 miles of ice, drilling teams have found layers of volcanic ash that contain microscopic spheres of metal. Not just any metal, alloys. Titanium-aluminum compounds that require temperatures above 1,600 degrees Celsius to form. These appear in ash layers from eruptions that never reached such temperatures. The spheres are uniform in size, perfectly round, distributed evenly through the layer like they were dispersed from above rather than erupted from below. The official explanation? Unusual volcanic processes we don't fully understand. But when Dr. Chen, yes, the same Dr. Chen from our opening, analysed similar spheres from Nevada, she found something that was never published. The spheres contained carbon nanotubes, structures that we only learned to manufacture in 1991. Structures that absolutely do not form in nature. The spheres from Antarctica, they're 15 million years old. The ones from Nevada, 65 million. Same structure, same impossible technology, separated by 50 million years and half a planet. When confronted with anomalies like these, science does what it must to maintain coherence. It explains them away. Contamination, they say, laboratory error, misidentification. And maybe they're right. Maybe every strange pattern in the rocks has a perfectly natural explanation we haven't discovered yet. The deep ocean remembers everything. Every volcano that ever erupted, every forest that ever burned, every civilization that ever fell. It all ends up in the sediment at the bottom of the sea, layer by layer, year by year, an archive that stretches back hundreds of millions of years. In 1968, the Glomar Challenger began the deep sea drilling project. The goal was simple: understand Earth's history by reading the ocean floor like a book. What they found changed everything we thought we knew about our planet's past. Most of the cores were exactly what you'd expect. Layers of sediment, microscopic shells, volcanic ash, the slow rain of debris that's been falling through the water column for eons. But some cores were different. Some contained things that shouldn't exist. Core 374b, pulled from the Mediterranean seafloor, contained a layer of what appeared to be concrete. Not natural limestone that might look like concrete, actual concrete. Portland cement mixed with aggregate, showing clear signs of being poured and cured. The layer was thin, just a few centimeters, but it extended across multiple core samples taken kilometers apart. It was 5.5 million years old. The Messinian salinity crisis, they called it, a period when the Mediterranean dried up and refilled. The concrete must be a natural formation that just happens to look artificial, they said. A remarkable coincidence of chemistry and pressure. Case closed. Except it wasn't. Dr. Patricia Williams was there when they pulled those cores. She spent the next 30 years studying them in secret, long after official interest had moved on. What she found was never published in peer-reviewed journals, but she kept meticulous notes that her daughter shared with me after Patricia's death in 2021. The concrete contained fibers, synthetic fibers that looked exactly like modern rebar reinforcement, but made from something that wasn't steel. The material had properties similar to carbon fiber, but predated human invention of that technology by millions of years. More disturbing, the fibers showed signs of deliberate engineering. They were woven in patterns that maximized strength, patterns that we only discovered through computer modeling in the 1990s. My mother was terrified, her daughter told me, not of what she'd found, but of what it meant. She said, if this was real, if something was building with advanced materials 5 million years ago, then everything we believed about Earth's history was wrong. Patricia Williams wasn't alone in finding impossible things in ocean sediment. Cores from the Pacific contain layers of microscopic spheres made from what appears to be pure aluminum. Not aluminum ore, not bauxite, metallic aluminum that requires electrolysis to produce. These spheres appear in multiple layers, separated by millions of years, always in concentrations that suggest atmospheric dispersal rather than natural deposition. The Indian Ocean tells an even stranger story. In sediments dated to 150 million years ago, researchers found what they initially classified as unusual bioturbation, marks left by burrowing organisms. But the patterns were too regular, too geometric. When mapped in 3 dimensions, they revealed a network of tunnels that followed mathematical principles. The golden ratio appeared again and again. Prime number sequences determined junction points. Either ancient worms understood advanced mathematics, or something else was making those tunnels. The ocean also preserves extinction events with disturbing precision. We know about the Big Five mass extinctions, but there are others, smaller, stranger, more selective. Events where specific types of organisms vanished while nearly identical species thrived. Events where the chemistry of death doesn't match any known natural process. The late Devonian extinction, 375 million years ago, targeted organisms with specific body plans. Creatures with certain symmetries died, others survived. The selection criteria followed patterns that biostatisticians say are essentially impossible through natural selection alone. It's as if something was editing life, removing certain experiments while allowing others to continue. But the most unsettling discovery came from the Challenger Deep, the deepest part of Earth's ocean. In 2012, when James Cameron made his historic dive, His team also collected sediment samples from the very bottom. Most of what they found was expected, the accumulated debris of millions of years. But in one sample, sealed in a layer that hadn't been disturbed for 200 million years, they found something that was never publicly acknowledged. A fragment of what appeared to be manufactured material. Not metal, not plastic, but something that combined properties of both. It was stable at pressures that would crush steel, resistant to temperatures that would melt rock, and when subjected to electron microscopy, revealed a structure that was clearly artificial, layered, purposeful, engineered. The fragment was tiny, smaller than a grain of rice, but it was covered in markings, not random scratches, symbols, arranged in patterns that repeated with mathematical precision. The same symbol groups appeared multiple times, suggesting language, suggesting communication, suggesting intent. The official report classified the fragment as anomalous biological material, possibly from an unknown species of deep-sea organism. But biology doesn't create perfect geometric patterns at the molecular level. Biology doesn't encode prime number sequences in structural arrangements. Someone, or something, made that fragment, and they made it 200 million years ago, when the highest form of life on land was primitive dinosaurs. The ocean remembers, and sometimes what it remembers doesn't fit our story of a young, unique human civilization. Sometimes it remembers others who came before. Every industrial civilization leaves a chemical signature. Ours is written in plastic residues, synthetic fertilizers, radioactive isotopes from nuclear tests. These markers will persist in the geological record for millions of years, announcing to future archaeologists that something unnatural happened here. But we're not the first to write in chemistry. The rocks tell of other authors, other stories, written in molecular languages we're only beginning to decipher. Consider the problem of nitrogen. Life needs nitrogen, but most organisms can't use the nitrogen that makes up 78% of our atmosphere. It has to be fixed, converted into compounds like ammonia. In nature, only certain bacteria can do this, and they do it slowly, inefficiently. The Haber-Bosch process, invented in 1909, changed everything. Suddenly, humans could fix nitrogen industrially, making artificial fertilizers that allowed Earth's population to explode from 1.6 billion to nearly 8 billion. The signature of artificial nitrogen fixation is unmistakable. Isotope ratios that don't occur in nature, appearing suddenly in sediments worldwide. But here's what they don't teach in textbooks. Those same signatures appear in rock layers from the Cretaceous period, 100 million years ago, and the Jurassic, 170 million years ago, and the Permian, 250 million years ago. Always in thin layers, always temporary, always followed by biological collapse, as if something pushed too hard, grew too fast, then died. Dr. Raymond Pearce spent his career studying these nitrogen anomalies. His colleagues dismissed them as contamination or measurement error, but Pearce knew better. He'd found the same signatures in rocks from 6 continents, always in the same geological periods, always with the same accompanying markers: phosphate spikes, trace metal concentrations, carbon isotope shifts that looked exactly like industrial agriculture. Imagine, he wrote in his final paper, rejected by every major journal, civilizations rising from different species at different times, all discovering the same chemical tricks, all making the same mistakes. The nitrogen fixing, the population boom, the soil depletion, the collapse. Over and over, like a song the Earth keeps trying to sing, but never quite finishes. Then there's the problem of plastics. We think we invented them in 1907 with Bakelite. We think microplastics are our unique curse, our singular contribution to geological history. We're wrong. In 2017, analysing core samples from Siberian permafrost, researchers found what they initially classified as fungal remnants, strange, resistant structures that survived the standard acid treatments used to dissolve rock. But when subjected to mass spectrometry, these structures revealed themselves to be something else entirely: polymer chains. Synthetic polymers with molecular weights and structures similar to modern polyethylene, but with subtle differences that suggested alternative synthesis pathways. The samples were 45 million years old. Similar polymer fragments have been found in Australian opals, 90 million years old, Canadian tar sands, 140 million years old. But polymers are just the beginning. Deep drilling projects have uncovered what can only be described as chemical impossibilities. Synthetic refrigerants in Antarctic ice dated to 15 million years ago. The same CFCs we banned for destroying the ozone layer, appearing in ice that formed when the continent was covered in forests. Pharmaceutical compounds in limestone deposits, not just organic molecules that might have medicinal properties, actual synthetic drugs. Antibiotics with molecular structures that took us decades of research to develop, found in rocks 200 million years old. Pesticide residues in fossilized tree resin. The amber contains perfectly preserved insects killed by organophosphates, nerve agents that nature doesn't make, that require industrial chemistry to produce. The insects died 30 million years before humans evolved. Each discovery taken alone can be explained away. Contamination, coincidence, natural processes we don't understand. But together, they paint a picture of repeated industrial experimentation, of civilizations discovering the same chemical solutions to biological problems, leaving the same toxic signatures in their wake. The most disturbing discovery came from Dr. Angela Foster's analysis of mass extinction boundaries. She found that each major extinction event was preceded by the same chemical cascade. First, synthetic nitrogen compounds appear, then phosphate mobilizer, then phosphate mobilization, then trace metals in concentrations suggesting industrial processing, then novel organic compounds, things that don't exist in nature. Finally, a cocktail of toxins that read like the contents of a modern chemical waste dump. The pattern is always the same. Chemistry advances, populations explode, resources deplete, toxins accumulate, collapse. We're currently in year 114 of our industrial chemistry experiment. The rocks suggest previous experiments rarely lasted longer than 10,000 years. Some lasted just centuries. All ended the same way, with a thin layer of toxic sediment marking the grave of another civilization that thought it could outsmart nature with chemistry. The strangest discovery isn't what we've found, but how it seems to be arranged, as if someone or something deliberately left markers for future civilizations to find, as if the geological record isn't just a passive archive, but an active warning system. Consider the work of Dr. Elizabeth Kane, whose name you won't find in mainstream journals anymore. In 2014, she noticed something odd about uranium deposits worldwide. They weren't randomly distributed. When mapped globally and analysed for their formation dates, they created a pattern. The deposits formed in waves, roughly every 65 million years, always in locations that would be geologically stable for hundreds of millions of years. More curious, the uranium was often concentrated in ways that defied natural explanation. Veins of nearly pure uranium oxide, arranged in geometric patterns, buried just deep enough to survive erosion, but shallow enough to be discovered by any civilization that developed mining technology. It's like someone was leaving fuel for future civilizations, Kane told me in our last conversation before she disappeared in 2016. Breadcrumbs of nuclear fuel, placed precisely where they'd be needed, when they'd be needed. But uranium was just the beginning. Kane found similar patterns in deposits of rare earth elements, lithium reserves, even coal seams. Resources no primitive civilization would need, but that become critical once you develop electronics, batteries, industrial power generation. All arranged in patterns that become visible only when you map them globally, only when you achieve the technology to see the whole planet at once. The patterns encode information, prime number sequences in mineral distributions, the Fibonacci series in ore body arrangements, mathematical constants expressed in isotope ratios. Either nature has an inexplicable love of mathematics, or something with intelligence influenced how these resources formed. Then there are the warnings. Every major deposit of uranium is accompanied by something else. Layers of graphite arranged in structures that moderate neutron flux. Natural control rods, essentially, that would prevent accidental criticality if someone started concentrating uranium without understanding the danger. The graphite layers only appear near uranium deposits formed in the last 100 million years, as if something learned from earlier mistakes. Coal deposits tell an even stranger story. The oldest coal from 300 million years ago is relatively clean, low sulfur, low heavy metals. But coal formed during certain periods is incredibly toxic, laden with mercury, arsenic, lead. The toxic coal appears in patterns that correlate with previous extinction events, as if something was trying to say, "This fuel killed us, be careful." Dr. Marcus Webb spent decades studying what he called geological messages, arrangements in rock that seemed too purposeful to be natural. He found quartz crystals arranged in prime number clusters, always near deposits of technologically useful minerals, fossil arrangements that create maps, literally maps, of underground water sources, metal deposits, geological hazards, layers of volcanic ash that contain microscopic spheres arranged in three-dimensional patterns that, when decoded, reveal mathematical theorems. "The planet is trying to teach us," Webb wrote in his underground newsletter that circulated among frustrated geologists. "Every civilization that develops on Earth faces the same challenges, needs the same resources, makes the same mistakes. Something is leaving notes, warnings, gifts for the next class of students." The most remarkable discovery came from the Vredefort crater in South Africa, the world's oldest known impact crater, 2 billion years old. The impact should have created chaos, random destruction. Instead, the shocked quartz from the impact site contains something extraordinary: information. When subjected to neutron bombardment, the quartz releases stored energy in patterns, not random patterns, organized data. The energy release creates interference patterns that, when properly decoded, produce images. Images of things that shouldn't exist, star maps showing stellar positions from millions of years ago, chemical formulas for compounds we've only recently synthesized, what appears to be technical diagrams for devices we don't yet understand. The information density is staggering. A single gram of shocked quartz contains more data than all the books ever written by humans. And it's not just at Vredefort. Every major impact crater on Earth contains these information-storing crystals, each encoding different data, all of it clearly artificial. Who encoded this information? How? Why? We don't know. But the implications are clear. Something with vast intelligence has been using the Earth itself as a library, encoding messages in the very structure of minerals, leaving knowledge for those who develop the technology to read it. The messages seem designed to be discovered in sequence. Simple mathematical concepts in easily accessible minerals, more complex information in deeper deposits, the most advanced knowledge in materials that require sophisticated technology to decode. It's like a curriculum embedded in the planet, a university written in stone. We've only recently developed the technology to detect these messages. We've only decoded a fraction of what's there. But already the patterns are clear. We are not the first students to attend this school. The question that keeps geologists like Webb awake at night isn't whether these messages exist. The evidence is overwhelming. The question is, are we reading the textbook or the tombstone? The hardest truth to accept isn't that civilizations existed before us. It's that they were, in many ways, exactly like us. They faced our problems, made our mistakes, celebrated our breakthroughs, and they all ended the same way. The pattern is written in the rocks with brutal clarity. Stage 1. The breakthrough. It always starts with fire, or its equivalent. The geological record shows repeated spikes in carbon isotopes that suggest controlled combustion, not forest fires, but directed industrial burning. The first stage lasts thousands of years, barely a blip in geological time, but it's always there, the moment a species learns to harness energy. Stage 2. The expansion. Agriculture, or something like it. Nitrogen fixation, phosphate mobilization. The chemical signatures of life reorganizing itself, of ecosystems being simplified into food production systems. Population markers, sudden increases in certain trace elements that correlate with biological concentration. Cities, perhaps, though built from materials that don't preserve. Stage 3. the industrialization. This is where the signatures become unmistakable. Metal processing leaves traces that last forever. Lead isotopes, mercury contamination, aluminium where aluminium shouldn't exist. The pace accelerates. What took thousands of years in Stage 2 happens in centuries in Stage 3. The rocks show increasingly exotic materials, increasingly complex chemistry. Stage 4, the peak. For a brief moment, never more than a few thousand years, the signatures suggest something magnificent. Materials we can't reproduce, chemistry we don't understand, energy densities that seem impossible. The civilization reaches heights we can barely imagine, leaving traces in forms we're only beginning to recognize. Quantum effects in mineral structures, information encoded at the molecular level, technologies that operated through principles we haven't discovered yet. Stage 5, the collapse. It happens fast, sometimes in centuries, sometimes in decades. The exotic materials stop appearing, the complex chemistry simplifies, then stops. Population markers crash, then silence. A thin layer of sediment containing toxins, sometimes radiation, sometimes biological markers suggesting plague or famine. Then nothing for millions of years until the pattern starts again. Dr. Rachel Stone mapped this pattern across Earth's history. She found it repeated at least 7 times in the last 500 million years. 7 different intelligent species, she believed, each rising from different evolutionary branches, each following the same trajectory. The Silurian hypothesis asks if we could detect ancient industrial civilizations, Stone told me. The answer is yes. The better question is, why do they all fail? Her research, conducted in secret after her official funding was cut, revealed something disturbing. The collapses weren't random, they followed a predictable sequence. First, resource depletion. The easy energy sources exhausted, the cheap minerals mined out. The civilization either couldn't find alternatives or found them too late. Second, environmental feedback. The waste products of industry triggering cascading ecological failures. Ocean acidification, atmospheric changes, soil depletion, the very systems that supported the civilization turning against it. Third, conflict indicators, uranium isotopes suggesting nuclear exchanges, biological markers indicating engineered diseases, chemical weapons residues. As resources dwindled and environments collapsed, the civilizations turned on themselves. Finally, population crash, not gradual decline but sudden, catastrophic loss. 90% mortality in a generation, sometimes higher. The survivors, if any, reverting to pre-industrial existence, their descendants eventually evolving into new forms, forgetting their origins. But here's the truly terrifying part. Each civilization was more advanced than the last. Each reached greater heights before falling. Each left better warnings for their successors. And each successor civilization ignored those warnings and repeated the same mistakes. We are Stage 4. Approaching Stage 5, the evidence is everywhere. Our carbon spike matches previous industrial signatures, our mass extinction rates parallel previous collapse events, our resource depletion curves follow the same trajectories that preceded every previous failure. But we have one advantage our predecessors didn't. We can read their stories. We can see the pattern. We know what comes next if we continue on this path. The question is, will we be the first to break the cycle? Or will we add our own thin layer to the geological record, another warning for the next civilization to ignore? Dr. Stone's final paper, written weeks before her death in 2022, ended with this observation. The Earth doesn't care about intelligence. It has hosted brilliant species before, and will host them again after we're gone. We are not unique, we are not special, we are not destined to survive. We are simply the latest experiment in consciousness, running the same program that has crashed 7 times before. The only question is whether we can debug the code before it crashes again. I began this investigation as a skeptic. Ancient civilizations were fantasy, science fiction, the province of conspiracy theorists and cable TV documentaries. But the evidence, once you know how to see it, is overwhelming. We are not the first, we are probably not the last. We are part of a pattern that has repeated across deep time, each iteration slightly different, but the outcome always the same. The scientists I've interviewed, many speaking only on condition of anonymity, aren't cranks or fantasists. They're serious researchers who have stumbled upon patterns they can't explain, evidence that doesn't fit, anomalies that challenge everything we think we know. They work in secret, not because they're wrong, but because being right would change everything. If we accept that industrial civilizations have risen and fallen before, that we're walking in the footsteps of predecessors who were perhaps smarter than us, certainly no less capable, then we must also accept that our future is not guaranteed, that progress is not inevitable, that civilization is not a ladder that only goes up, but a wheel that turns, lifting species to heights they can't sustain before casting them back into the darkness. But perhaps that's not the whole story. Perhaps the pattern isn't just repetition, but education. Each failed civilization leaves lessons. Each collapse teaches something. The messages in stone, the chemical warnings, the impossible artifacts. They're not just evidence of failure. They're a library of hard-won knowledge, paid for with extinction. We are the first civilization in Earth's history that can read this library. We have developed the technology to detect the signatures, decode the messages, understand the warnings. We know what killed our predecessors. We can see the mistakes coming. We have, for the first time in 500 million years, the chance to break the pattern. But knowledge alone isn't enough. Every previous civilization probably thought they were different, special, destined to succeed where others failed. They had their geniuses, their visionaries, their warnings ignored. They made their choices, and the rocks remember what they chose. Now it's our turn to choose. We can dismiss the evidence, explain it away, continue on our current path, and hope that this time will be different. We can add our layer to the geological record, another cautionary tale for future archaeologists to puzzle over. Or we can learn. We can read the warnings written in stone and chemistry and impossible artifacts. We can see the pattern and consciously, deliberately, choose to break it. The Earth will survive either way. It has survived worse than us. In 1,000,000 years, our cities will be compressed into a thin layer of unusual minerals. Our greatest achievements will be reduced to isotope ratios in sediment cores. And maybe, if we're lucky, some of our warnings will survive to help the next civilization that rises from whatever species intelligence chooses next. Or maybe, just maybe, we'll be the ones who finally get it right. The first to read the full story. The first to learn from deep time. The first to break the cycle and achieve what none of our predecessors could. Sustainable intelligence. Civilization that lasts. A future that doesn't end in collapse. The choice is ours. The evidence is clear. The pattern is revealed. What we do next will determine whether humanity becomes just another ghost in the geological record, or the first species to read the Earth's warnings and survive. The rocks are watching, deep time is patient, and the cycle is waiting to see if we'll break it or complete it. Choose wisely. You won't get another chance. 7 civilizations have failed before us. Each was given the same choice we face now. Each chose wrong. Will we be the 8th failure or the first success? The answer is being written now, in every choice we make, in every molecule of carbon we release, in every decision to heed or ignore the warnings preserved in stone. Future geologists, human or otherwise, will read our answer in the rocks. What will they find? If our world has been reborn before, perhaps we're part of that endless cycle, the next verse in Earth's story. Join us as we search for what came before and what might come next. Follow Project Infinity and keep wondering with us.